Welcome to my YouTube channel. Today I'm gonna talk about home team advantage. Goal of this video is to see if lower ranked teams more likely win at their home than away games. And also we will find differences between home and away games in a number of shots, shots on target, corner kicks, fouls, yellow cards and red cards. Procedure: first of all, import the data, then compute the ranking or accumulated points, compute the probability, find the variables, create a box plot from the variables, then conduct a t-test to see the difference, then finally create Excel files. I'm gonna show you how to do those by using MATLAB, and I'm gonna show you how to do statistical analysis in spreadsheet and R. So let's go to MATLAB. Okay, MATLAB. So first of all, I'm gonna get the data and import it into MATLAB. In this video, I'm gonna use this website called Football Data. This website gives you all data about Premier League, Bundesliga, Serie A, Liga Española, blah blah blah. But in this video, I'm gonna use Bundesliga season 2019-2020. You just click it here and download it and import it into MATLAB. I already have data in my MATLAB, so I'm just gonna run this code and save the data into variable called Germany. Let's take a look at it. So this is raw data. Dimension is 306 times 105, which means there are 306 rows and 105 columns. Each row represents each game, each column represents each variable. In this video, I'm gonna use variable called home team, away team, FTL, which is final time result, and home shots, away shots, home shots on target, away shots on target, home fouls, away fouls, home corner kicks, away corner kicks, home yellow cards, away yellow cards, home red cards, and away red cards. Then let's go to the next step, which is find accumulated points or ranking. Unfortunately, this data doesn't have accumulated points or ranking, so I have to calculate game by game. So first line defines the teams. So if I run this, I defined teams in Bundesliga, which is 18 teams, and the points. This one makes sure all teams start from 0, and there is a long for loop. First for loop goes from 1 to 306 game, and the second for loop goes team by team in this variable. And there is a if statement. Stack-on function compares two variable. In this case, Germany home team and teams I just created right here. What does it mean? So for example, for the first loop here, it goes to Germany.HomeTeam1, which is Bayern Munich. Then in this team variable, the loops or if statement finds Bayern Munich. So it goes from Augsburg, and Bayern Munich is the second index. So in the second loop, this if statement is satisfied because Bayern Munich and it's true. This one is satisfied, and there is another stack-on function. In this case, comparison is between Germany final time result and the capital H. FDR is full time result, which is right here. D means the game is tied. H means home team won the game. A means away team won the game. So what I want to know here is home team won the game, and the second if statement pretty much the same, but in this case away team if they won the game, and third if statement home team if they tied, and same thing away team if they tied. And if the home team won the game, for example, they gained 3 points. If away team won the game, they gained 3 points. And the same thing for the tie, they gained 1 point. And for the away team, they tie, they gained 1 point. And this keeps going until the last game, which is 306 game. Then game by game and team by team, the points right here goes to here, this line, and create a table with team's variable. Then the table is sorted by points in descending order, which means team which has highest point goes to the top of the table, which means in the first index of the table. Then all rank is accumulated in rank season game by game, but I just created a space just front of the first game because all teams start from 0. Then I just put the table with just 0 points in the really first index. And I'm gonna run this and you will see what I mean. So rank season, just what I say, in the first table it's just all 0, but if you take a look at the second table, Bayern Munich and Hertha already gained 1 point because they tied in the first game. And as you imagine, or as you guess, if you go to the last table, you will see this is the final ranking table. So Bayern Munich won this season. Then second step is over. We go to the next step, which is find games which lower ranked team win or tie at their home and away games. So for the topic of this video, I only need home games, which is because the topic is home team advantage. But if I don't have away games, I don't have something to compare, right? So that's why I just put the away games right here. So what I mean by that is I'm gonna count a number of games which lower ranked teams win or at least tie at their home games, and I'm gonna switch home and away, and I'm gonna count the number of games which lower ranked teams win or at least tie at their away games. So I'm assuming that it's much tougher to win the game against higher ranked team at their away games compared to home games, because if there is a home team advantage, much easier to win at their home, right? So I'm gonna calculate that and find the probabilities. So first two lines is just the counter variables, and actually third and fourth, this is also counter variables. And the for loop goes from game 1 to game 306, and I'm gonna save the variable home team into home and away team for the away. Then I'm gonna extract all teams in the table into variable called team and the points as well separately. And I'm gonna use find index to find the index if the string in the table team matches with home team. So what I mean by that is team is the table, which is one of this. Let's say in the first loop, the team's table is right here from Augsburg to whatever is here. And I'm gonna find the home, which is in the first game, which is Bayern Munich as you saw. And I'm gonna find team called Bayern Munich, here in the second index, and find the function save 2 as an index, and I'm gonna use this 2 to find points right here. Then I'm gonna find the value in the second index of points, which is 0 of course, because this is actually before the first game, so everyone gets point 0. So home point is 0, and the same for the away point, it's 0 obviously because this is before the first game. Then it goes to the if statement and compare the points which home team get and away team get. Obviously the higher points, higher the ranking, so what I want to make sure is home team gets less points than away team. This one makes sure home team is lower ranked compared to away team. Then if this is the case, it counts here, game H. As I said, this is just counter variable, it keeps counting if this is the case. And there is a second if statement, which means game Germany FTL, final time result, and H, which means home team won the game or tied at least. Then if this is the case, save the index and another counter variable, then pretty much that's how you count all games and games which lower ranked team win or choose tie at their home game. And do the same thing for the away. Then I'm gonna run this and you will see what I mean. So a number of games which lower ranked team play against a higher ranked team in their away games. 136 games in total, and for the home 148. And the index it's right here. So lower ranked team won or choose tied at their away is 68 games, and for home 72 games. And I'm gonna do calculation, which is just divide number of games which they are choose tied by number of games in total. Let's run this, and you will find a probability. It's very surprising because lower ranked team won or at least tied at their away games more than at their home teams when they play against higher ranked teams. I don't know the secret behind or reason behind, but that's the case in Bundesliga. So maybe lower ranked team get encouraged when they play at their away when they play against higher ranked teams. It's very interesting. Then this step is over. We go to next step, which is finding variables. So I'm just gonna use the index I just found out in here. I'm gonna only count the games which lower ranked teams win or choose tie at their home. Then I'm just gonna extract the data: home shots on target, home corner kicks, home fouls, home yellow cards, home red cards, and same for away. Then I'm gonna run this. Then we go to the next step, which is creating box plot. I'm just gonna combine all variables right here into variable or bar h and bar way, and this for loop that's model the data or convert the data a little bit. So variable here or like a bar variable, this one has away shots, home shots, away shots, home shot on target, away shot on target, and blah blah blah. So just repeating home, away, instead of just home in this side and away in that side in the variables, because later on I'm gonna use box plot function. If you wanna compare home and away, you just wanna put home and away like next each other. So I'm gonna show you what I mean. So I'm just gonna run this. So this is just box plot, home shots, away shots, home shots on target, away shots on target, home corner kicks, away corner kicks, blah blah blah. So you can easily compare two variables, home and away, because those are just right next to each other. You will see overview of the variables, and probably you just notice there is maybe difference between home shot and away shot. Same thing, shot on target and shot on target, and probably nothing else. Probably same for the corner kicks, probably same for fouls and the yellow cards, red cards. It looks very weird because red card is such a rare event, so probably sample size is very low, so that's why it's just weird, and I don't think this is valid, even though it's statistically significant difference between home and away. But I'm just gonna keep it, and I'm gonna do t-test, which is right here, conduct a t-test. So I'm gonna do two sample t-tests. So I'm just gonna use this function and put one variable here and another variable here, and as you saw, I put all home variables in bar H and all away variables in bar A. So I'm just gonna extract one by one by using for loop. So it goes from home shots, I think, and away shots, home shot on target, away shot on target, and keeps going until red cards, yes, and save p-values and confidence interval, and just create a table and write a table to save the table into MATLAB with Excel format. Okay, I'm gonna run this. Let's see p-value. This is here. So the first p-value is home shots versus away shots, and p-value is less than 0.05, so there's a difference between home and away. And the same thing for the shots on target, there's a difference. No difference, no difference, no difference, and there is a difference in red cut, but like I said, I don't think it's valid because sample size is very low. And if I look at confidence interval, which is right here, so if this is positive value, I usually take a look at lower boundary, which is right here, and it's just 0.0174, which is less than 1, which means I don't think this is practically relevant because it's just less than 1. It doesn't really make sense because you count shots like 1, 2, 3, 4 like a discrete number. It never be like 1.5 shots or 0.5 shots, blah blah blah. But statistically speaking, it's possible to go to like less than 1, for example, and it's obviously less than 1, which means difference is very small. But t-test says statistically different, but it doesn't mean it's also practically relevant. Then same thing for shots on target, less than 1. Maybe there's a difference, but maybe not practically relevant. And corner kicks, yes, there's no difference, red curves, it's invalid, I think. So I'm not gonna rely on this value, to be honest. So finally, I'm gonna create Excel files. I'm just gonna put bar here. I just created like a couple sections ago, and by using table function. And if I put just one variable in table function, it just create one column, even though there are 6 columns inside. So I'm just gonna use this function called split bars. This function split bar into whatever number of columns in table right here. Then I'm gonna put a name on each column with X name, which I created right here. It's just the abbreviation of home shot, away shots, home shots on target, blah blah blah. Then write the table to save the table into MATLAB with Excel format. Okay, so I'm done with everything in MATLAB, and I'm gonna show you how to do statistical analysis in spreadsheet and R by using this Excel file. So let's go to spreadsheet first. Okay, spreadsheet. So left table you are seeing now is just the data. It's just exported from MATLAB. So pretty much the first row is home shot, away shot, shots on target, corner kicks, blah blah blah. It's just the variable names, and each row here is just each game, and there are 72 games in total. And I just created another table defining like a maximum, upper quarter, lower quarter, minimum. I just used function called max quartile with 3 because it's upper quarter, and the same thing but 1 for lower quarter, and minimum and min function. And I just defined maximum, lower quarter, upper quarter, minimum for each variable, home shot, away shot, home shot on target, blah blah blah. Then what I can do is just select the data, click insert, go to chart, and change the chart to candlestick chart, which is pretty much box plot. Okay, this is a box plot, pretty much. It's kind of tough to see because there is no mean or median bar supposed to be here, but you see kind of overview of variables. Then, and the next step is find the p-value. So I just use t-test function. You just need to put one variable, for example home shots, like 2 to all the way 73, and do the same thing, away shots from 2 to 73, and I put 2 because it should be two-tailed test. Hypothesis is just home shots equal to away shots, or home shots unequal to away shots. Then I put 3 because it should be two sample t-test with assumption of unequal variance which means the variance in home shots and away shots might be unequal. In other words, it's wedge test. Then I get this p-value, shots on target, and blah blah blah, and you see the exactly same value as you saw it on MATLAB. So there's a difference in shots on target, but no for corner kicks, fouls, yellow cards, red cards, invalid. Then next step is calculating confidence interval, but I tried to find a function or add-on to calculate confidence interval, but I couldn't. I found YouTube videos, websites showing how to calculate confidence interval manually, but to be honest, it doesn't make sense because you can use R and Python for free if you have laptop and a Wi-Fi connection or internet connection, and there is a function to calculate confidence interval. It just put the variable inside the function and it calculates automatically, basically. You just need to find the mean, standard deviation, sample size, and you just calculate it manually. But like I said, it doesn't really make sense. You have access to R and Python. It takes less time, less effort. So I'm gonna show you how to do it in R. So let's go to R. Okay, R or R Studio. So first of all, I'm gonna import the data. So click Excel and browse. Okay, so this is the data I just created in spreadsheet, or exported from MATLAB and created in the spreadsheet. So there are some extra variables right here, but I only need from 1 to 12, and I'm gonna import this anyway, and I'm gonna just extract columns of the data right here with this code. So what I'm gonna do is just create a sequence like 1 to 11 by 2, which means the column should be 1, 3, 5, 7, 9, 11, because that's for home team, and I'm gonna do the same thing but sequence from 2 to 12 by 2. So if I do this, you create 6 variables, you just extract the 6 variables and a 72 observation, which means 72 rows and 6 columns, and the same thing for the weight. Then I'm gonna create a box plot by just using box plot function, and you see the box plot right here. It's much easier to interpret and take a look at because there is a mean line or like a median line here, and you can compare home and away very easily. And the two sample t-test, so I'm just gonna use for loop, and this one goes from 1 to 6, and I'm gonna save x, which is variable for home team, and y for variable for away team. I just put function called data frame because for t-test function, the variable inside or input variable should be data frame or matrix at least. But like I saved this variable with I think table format, so I have to change it to data frame, and I just put print function to print everything here. So if I run this, you get the whole table right here. So p-value for shots, because this is the first summary table. So p-value, okay, hypothesis to difference in mean is not equal to 0, so this is true because now hypothesis is equal, so I just reject it. So there's a difference between home and away, and this is 95% confidence interval, and this value is exactly the same value as you saw it on MATLAB. And for the second summary table, it's shots on target, p-value is less than 0.05, so there's a difference, and this is confidence interval. Then same fouls, or this is corner kicks, sorry, and fouls, yellow cards, and red cards, and all makes your life much easier, to be honest. So it doesn't hurt. Think about if you have to do same thing over and over again. Especially takes much longer than R or R Studio. Even you have to kind of practice or learn a little bit at the beginning. So that's it. Thank you for watching my video, and